Yes. So, hello everyone. Welcome back to Geeks for Geeks. My name is Muskan Agarwal, and today we are here with yet another very interesting webinar. So, we have a very special guest today, but before I add him to the stream, just confirm me in the comment section if I am perfectly visible and audible so that there are no network glitches in this entire webinar. It is going to be a really interesting one, and we have a really great offer for all of you as we all know that GCL is coming up. So, yeah, just give me a thumbs up and I will quickly tell you what the offer is all about and what this webinar is going to be all about. Right. I'll wait for another 1 to 2 minutes so that more people can join in. We have Anshul with us today, so he is going to teach us all about bits and manipulations. So it is going to be a really interesting one. So stay tuned till the end. Correct. Just give me a thumbs up in the comment section so that I will know that there are no network glitches and you guys can hear us perfectly. Also, there is one form in the description box below in case you guys have any questions or any queries that you would like us to solve. So there is a Google form given in the description box below. You guys can just fill it up and get your queries answered. Right. Okay. And talking about the course that I was saying, that we have a coupon code of LIV20 off for flat 20% off on our DSA live course for working professionals. So the same is being displayed down here. So, okay, so you guys can avail this course. So I will tell a little bit about this course. So basically, this is a live course which is designed for aspiring SDs who are looking to switch to top product-based companies. So we have mentors and questions like practice questions, doubt assistance, and a lot more. Okay. Okay. So thank you, Bharat. Thank you for confirming. Now I will add Anshul to the stream. Hi, Anshul. How are you doing?
Yeah, hi Muskan. Yeah, I'm doing good. What about you?
Yeah, I am doing good as well. So we can start with the webinar. But before we start, can you give us a brief introduction about yourself so that the audience connects with you better?
Yeah, sure. Hey everyone, I am Anshul. I basically a software engineer working in the Microsoft. So yeah, that's the brief about me. And I did my BTech from the Triple IT Hyderabad. So
Hmm.
that's about my education.
Right.
Yes. So
So I can
I
already
think
see
we.
a lot of, yeah, yeah, continue.
So I think we can start.
Yes, definitely. There are a lot of people already in the live stream. So from here on, you can take up Anshul. Right.
Sure, sure. Hey everyone. So as you already know, we are in this webinar we are learning about bets and manipulation, what tricks and what techniques which will be useful in solving the bets and manipulation questions. I will be telling you about that. So yeah, let me know once is you can is visible, you can see my coder pad and sharing my screen. Hey everyone, are you able to see my coder pad? Let me know in the comments. Yeah, so we can go ahead. So today's lecture is on the bits and manipulation. So first thing you can tell me like so first thing we will discuss like how will we write any number in decimal. Like suppose the number is 125, or suppose a number is any number. Like it's here I have taken the example of 125 just for understanding like how we write any number in a decimal number system. So how we will break down that number. So it's 5 into 10 raised to power 0 plus 2 into 10 raised to power 1 plus 1 into 10 raised to power 1 multiplied by 10 raised to power 2. So this way we can break the number in a decimal number system. So same way we can have a binary number system also, like in which we can represent the number in 0 and 1 only. Like we can represent any number in 0 and 1. So why its binary number is necessary? Like in every machine, in every computer, we represent all the things in a binary number only. Like all the computer, all the calculations, all the executions that do using the zeros and ones only. So that's why we need the binary number. Like so, so basically, if you see, so in binary number system, we also call it as a uh, with the base two. Like if I say number is 101, so it's a binary. In binary 101 will be represented by 5. Like its decimal number will be 5. So 101 is in a binary and 5 is in a decimal. So here you can say like 5 is in the 5 is in the base 10, and here 101 is in the base number of system is 2. So basically it's just represent a 5 in the binary. So first we will see how we will represent any number in binary system. So like first we will take an example of 10. It's a basic mathematics like which we do in our ninth or 10th, like how we change a number into a binary system, just a basic mathematics. So like in any system, like not binary, like if you want to change into the octa system, like divide by 8. In any system you have to do, like you have to divide by that number only. Like for binary we will divide by 2. So first we will divide 10 by 2, we will get 5. Then we will get remainder as a 0. And then we got 5 divided by 2 is 2 and remainder as 1, and 2 divided by 2 is 1, so we got remainder as 0. So the binary representation of 10 will be 1010, like we got from here 1010. So that's how we got the binary representation of 10. For any number we can get, like I will take an example of any other number. Let's say number is 12. So 12 divided by 2 is 6, and remainder is 0. 6 divided by 2 is 3, and remainder is 1. 3 divided by, oh sorry, remainder is 0 here, and 3 divided by 2 is 1. Remainder is 1 here, and 1 divided by 2 is again 1. And basically you will, okay, we got the 1 here, so we don't have to divide again by 2. So here you got the binary representation of 12, 1100. So binary representation of 12 is 1100. So how you will like from this you got like how to convert decimal number into binary. But if you have to do the vice versa, like if you have given the binary number, then you have to convert a decimal number. So just how we got here, like we divided two, like here we divided it by its two, then we divided again two, we divided again two, so it's increasing the power only. So here if we can see like 1010, so how we are calculating, like first we will multiply zero, like ze- 0 with the 2 raised to power 0. So we then here 1, we multiply with 1, multiply 2 raised to power 1. Same again 0, multiply by 2 raised to power 2. And again 1, multiply by 2 raised to power 3. And we will add all this bit sum, we will got the 10. So this is the basic conversion. So this will be like we will see in the later class that how we will write the code of this conversions, like. So like this is the basic knowledge about like how we convert the number in like decimal to binary and binary to decimal. So this is the basic thing. I will. So and like now I will tell you about the what all the operators we have, and what are their functionalities with their examples. And then we will, in after 15 minutes we will do the questions about bits. So yeah, so our flow will be like that only. So there are two kind, like there are many types of operators we can say. First is logical operators. So logical operators will look like this. If you see here, it will be look like this. And is this, logical and is this, logical or is this, and logical not is this. And there are other, like we will see the ex- example of logical operators and the difference between the logical operators and the bitwise operators in the later part of this class. So first I will tell you about the bitwise operator. The class is for that only. So we will look more into it and deep into it, what is this and how it's working. So excuse me. So and is this, or is the single pipe, not is this, and XOR is represented by this. So this is the basic representation, and we will be using this representation in the code, like in like while writing the code, this will help. So I will tell you more about the bitwise and like how it will help, and like what is the syntax and what is the bitwise and do, what are the values we end and what we get. So we will look into that. So bitwise and the syntax of, like if you have given two numbers a and b, the syntax will be a and b. So this is the basically the bitwise and syntax. So I hope that will be clear. Just I am looking into. So yeah, taking the end of two things like A and B. So first we will check like what will be the bit combinations for like if you take the end of 0 and 0, you will get 0. If you take the end of 0 and 1, like you will get 0. And same if you take the end of 1 and 0, you will get 0. And if you take the end of 1 and 1, then you only get the 1. So in the other words, you can say that if a and b is equals to 0, like in other words, you can say like a and b is equals to 0 unless a equals to 1 and b equals to 1. It will be only like the end of two numbers will be only like end of two bits, so is only will only one when it both the bits are one, like A is one and B is one, then the end of those two bits will be one. Otherwise it will be zero in all the cases. So we will take an example like how you can calculate A and B, the end of both the numbers. So what does A and B means? Like A here is 21 and B here is 6. I have like represented their binary numbers also, like 1 0 0 1, and this for 6 it's 1 1 1 0. So I am taking the end of 21 and 6 here. So you can see like it's 21 above and 6 below. So if we take the end here, so one end of 1 and 0, like last digit, so it will be 0. Same here, 0 and 1 it will be 0. 1 and 1 will be only 1, otherwise all the numbers are like all the other conditions will be 0. So here we got 0 0 1 0 0. So the decimal representation of 100 is 4. So like we got here the answer is 4. So end of 21 and bitwise end of 21 and 6 is 4. So like this way you can calculate. Same way for or will be 0 or 0 will be 0. Otherwise this is the syntax of or, like A or B. So if any bit has 1, then the output will be 1. Otherwise it will be 0. So you can see here in the table, like only at one place we are getting 0. When A is equals to 0 and B is equals to 0, then the or of both the bits will be 0. Otherwise it will be 1. So we will take an example fast, so we can have a time to do the questions. So here, like A is 21. Again, I am taking the same example, and B is 6. The representation of their binary is here. So if we take the or here, like we will got the output 1 and 1 or with 0 is 1, 0 or with 1 is 1, 1 or with 1 is 1, and 0 or with 0 is 0, and 1 or 0 is 1. So we are getting the output here is 23. So A or B is 23. So that's about the bitwise OR operation. Similarly, we have one more operation, bitwise OR. So bitwise OR is syntax for bitwise OR is or B. Like it's just the syntax, and here the combination is like that. If the both the numbers are same, then it will be 0, and if both the bits are different, then it will be 1. So this is the meaning of XOR. So here you can see like 0 0 is 0, since both the bits are same, so we are getting 0. And if both the bits are different, then we are getting 1. So 0 XOR 1 is 1, 1 XOR 0 is 1, and 1 XOR 1 is again 0, since both the bits have 1 in the value. So we are getting 0. So I hope it will be clear, like what is XOR, what is OR, and what is AND. So it's the again the same example. We are taking the XOR of 21 and 6. So this is the 21, and this is the representation of 6. And we have taken the XOR and we got the value 19. Similarly, like 1 XOR 0 is 1, 0 XOR 1 is 1, 1 1s or 1 is 0, and zeros or 0 is 0. Since they are the same, like bits are same, so we will get 0. And 1s or 0 is 1. So we are getting the value as 19. So like there is one more bitwise operator. It's not. It's just basically taking the opposite of that bit. Like if bit is 1, then it not of that bit will be 0, and if bit is 0, then the not of that bit is 1. So the syntax is very easy, like just a not operator. So these are the basic bitwise operators. I think to see the comments. I think it's going fine. Yeah. So these are about the bitwise operator. Now we will see the two important operators which we will use in code. Like, so there is one operator is right. One operator name is right shift operator, which syntax is like this: a right shift of, like, double greater, like two times greater than sign is, like, eh, this is the right shift operator syntax. So what does this means imply? Like, what does this means? Like, what right shift operator means? So basically, implies that shifting the bits of a to the right by the x positions. Like, I will give you the example, and those bits which are in the last x places, they will be lost. So we will take an simple example here, so it will be more easy to you and more visible to you, like what is the right shift means. So 4 is right shift by the 2. So the binary representation of 4 is 1 0. Let's take example of 5, so it will be more easier to understand. 5, so binary representation of 5 is 1 0 1. So we will right shift it by 2. So what will be the right shift of by 2? Like, here x is 2. So we will lose this two last two positions here, and we will right shift e. So right shift by 2 here will have a, we will have a this value. So 5 right shift by 2, we will get the value 1. That's the output. So, like, you will, like, if you look into this pattern, you will get to know, like, what is the right shift exactly means. So basically, if you take example as 6, also 6 right shift 2, that's also 1. Similarly, we will take an example here, so you will get also like a bigger example. So a is here 29, and the binary representation of 29 is this, and x is 2. So, so a right shift 2 means, like, we will lose this two bits, last two bits here, and the output will be this: 0 0 0 0. Like, all the starting zeros will be not, like, all are useless. So we have this value left behind. So the output will be 7. So this is the how right shift operator works. So I was telling about some pattern here. So basically, the pattern here is like how many digits you, like, if you shift a 4 with only, like, right shift by only one, then you will lost the last 1 0 0. So you will lost the last zero. So you will have a value 0 1 0. So it's basically 2. So pattern here is like the number n divided by power 2 and the number x. So this will be your output every time if you do the right shift of a number n with x, you will get this, and this is an output. This is the pattern I was telling about. Like, so this is the right shift operator. I hope it will be clear to you. Let's see, like, what is the left shift operator. Similarly, there is, like, how right shift operator works. It's similar to kind of that operator. Just here we will shift the bits to the left. Before we are shifting the bits to right, now we will shift the bits to the left. So the syntax of this is a less than sign, double less than signs. Like, you can learn like that. Otherwise, it's very easy. So a left shift with x, like, so the it implies shifting the bits of a to the left by x positions. Like, in right shift we are shifting by the right by x position. Now we are shifting left by x position. So the first x bits are lost this way. So we can see here, like, what this means. So here we will take an example 4 again. So four digit number, the binary representation of 4 is 100. So more precisely, we can represent it like this also: 0 0 1 0 0. Like starting zero doesn't have any significance, but it will be more easier to understand. So if we left shift it by one, the output is 0 1 0 0 0. So the output here will be 8. Similarly, if we do 0 1 0 0 left shift by 2, it's 1 0 0 0 is 16. So you can see like the 4 left shift by 1 is 8 and 4 left shift by 2 is 16. So this is the basic, eh, like how we can calculate the left shift. So here the left shift calculation is like that. So the value of, we can take an example, same example we taken for the right shift. So here the value is 29 and the x value is 2. So we can shift 29 left shift by 2. So here we shifting the 2. So we are just removing this, like we shifted, like we added last 2 0 here and then we calculated the decimal representation. So it will be 116. So here again you see the pattern, right? So one time we left shift by 1, then we got 8. If we did the left shift by 2, we got 16. So basically the pattern is here: the number a multiply by power of 2 and x. X is the number from which we have the left shift, like the x positions which we have left shift. So every time we do the left shift, we will get this value. I hope it will be clear. So before moving, there will be the some tricks we have to learn. Like these are like while practicing, you will get like what all these tricks are. But I have written down for you like what all these tricks are. So like, so I will just go very fast here. Like will take you the example. So take a number here, 4 and 3. So 4 and 3 will be 100 and 0 1 1. So here if you will take the here if you will take the end of this, you will get the, like you will clear the lowest set bit of x. So okay, so here the lowest set bit of x is this one, right? This one. And if you will take the end, you will like get the output here 0 0 0. So you can see like taking end of 4 and 3, you are getting 0. So you have cleared the lowest set bit of x. So lowest set bit of x was here, and you have cleared like, so this is the, like if you need to clear the, like someone say will ask you like how to clear the lowest set bit of x, then you just have to take like the end of that number with the one less than of that number. So you will get the same here. Here you will like, I will take the example of this one also. So here, what is this? Again, I will take 4 and 3, and the note of them like 1 0 0, and Here it is the not operator. So we have the value 0, 1, 1. So what will be this? 1, 0, 0. And what will be the end of this 1, 0, 0 and 1, 0, 0? It will be just 1, 0, 0 again. So here you got the here you extracted the first set bit. Like the first set bit will be like if you run the loop here, so you will get the first set bit will be this one. So that how you will get, like someone will ask you like given a question, like given a big number like say 200, and you have to find out the first set bit of that number. So what you will do is like you will just take the note of that and you will find out like what will be the first set bit of that number. So similarly you will get for all, like this expression will give you the x with the run of the set bits starting at bit n and clear. So these are the some important tricks when you will do the questions, you will get to use to of this. So I am not taking the example of all this since it will go, like time will go in explaining this. So I have to look into the questions also. So yeah, in starting I was telling about the logical operators and the bitwise operators. So just a difference here, like bitwise operator will return like this, like like take a two numbers, two and one, two and one, and take the bitwise or, you will get three. And if you take the bit logical or, you will get the value in return as true. So this is the difference basically. You will like you must have realized that different this bitwise end and bitwise logical end will be different, and similarly the bitwise or is very different from the uh, logical or. So in logical and logical or, you will be getting the boolean values as a result. Like you can see 2 or 1 is true, 2 and 1 is true. You will only get false when it's 0. Like 2 and 0 is false. So that's the logical operator for you. So very similar to the fact that you can rewrite like this. Like in many programs, we write like A is equals to A plus B. So we write that like that A plus equals to B. In same way, we can write the bits like this. A is equals to A bitwise or with B. So like you can write like this also, this expression. And same way for and expression also, you can write like this. I think the basic concepts around the bit is clear to you. Let me check the chat if there is something in chat. Yeah, I think it's excuse me. So we covered the concept behind the bitwise operators, like how we can take the logical bits, what is the difference between the logical operators and bitwise operator, what is the right shift, what is the left shift, we have covered. Now let's see, like let's use those concepts here. Like let's solve some questions. I have some very interesting questions for you. So like first question here, it states that please don't look into the solutions. Like uh, we can solve these questions simultaneously. Like we can solve parallelly, you can solve also with in your notebook or in your laptop also, like where you are want to solve. So here the question states, given two arrays, both arrays are exactly same except for one number, find that number. So here I have given that array, like say suppose array A and it's suppose array B. So here the question states that both the arrays are same, but just one number is different in both the array. So if you can check, like in array A, we have 1 time 2, and in array B, we have the 1 time 2 also. Same way, we have 1 time 4, we have 1 time 5 also, but in array A, we have 2 times 3, and in array B, we have only 1 times 3. So, from looking into this question, we have the basic intuition that output will be the 3 only, since we have the one less time 3 in the array B. So, output will be 3. So, like, there are many approaches to solve these questions. Like, you can solve, like, yeah, like, the topic is bitwise, so you don't have to think that you can solve this question from the bitwise, like you have to use the bitwise operator. That's not the way. You can solve, like, in the this question in the many ways. So first I will tell you the naive approach, like what will be the naive approach for this. What we will take, like we will do like sum of all the numbers in the array A and sum of the all the numbers in the array B, and we will subtract them. So sum of array A and sum of array, I will write array A as A and minus sum of array B as B. So you will get the output, like what is the difference. So that's the one way. So the time complexity here will be, I will tell you the time complexity also in, so it's O of n. You while n is the number of arrays, number of elements in the array. So it will be O of n. So here the time complexity doesn't matter. Like it's the basic question. Like we are just learning how we can use the bits. So that's the knowledge we have to gain here. So that's the first way. Like I already told you about sum of first minus sum of second, you will get your answer. Now now we can use the bits here, like our bitwise operator. So I told you one operator, that was the XOR operator. So what XOR operator do here is, like if the numbers are same, it will just return zero, and if the numbers are different, it will return that like one. Basically, if one XOR zero, it will return one, and if one XOR one, it will return and zero. So here you can check like this. So we will take the XOR of all the A's and XOR of all the B's, and we will take the XOR of A and B also. So we will get our output. Like you can see here, I will tell you what I am trying to say. So here, like suppose the number here are the length of this array is n, and the one number will be less here, so it's n minus 1. So we will write a loop from 0 to n, from 0 to n minus 1, like it's n. So and we will take the XOR of all the numbers from that array. So what will be the representation here? So like XOR, first thing is like XOR from any number, like 2 XOR 0 is also 2. So that will not affect our answer. Like taking the XOR from 0 will not affect our answer. So we initialize our answer as 0. Now we will take the answer XOR 3. It will be 3, since it will not take anything. Then we will take 3 XOR 4. Then we will take 3 XOR 4 XOR 2. Then XOR 5. Then XOR, then XOR 5. Then XOR 3. Then, and we are taking the XOR of B also, right? So XOR 2, XOR 4, XOR 3 and XOR 5. So like here we can see like we have taken the XORs of all the numbers. So we already know like the XOR of two same numbers will be 0. So we can safely delete this 3 since we know there are two three, like there are three threes, so we can delete two threes from here since the XOR of those two numbers will be 0 and XOR of any number with 0 will be same, so there is no issues in that. Here again we can see that there are two twos, so we can delete those two twos also. Same way we can delete 4 also, and same way we can delete 5 also. So the number left here is 3. So from XOR we find out like if we solve this question also, like by taking XOR of all the numbers in the array A and B, and also taking the XOR of array after the getting the output of array A and array B XOR values, we got what's the different number which we want. So you can say like this is the pseudo code for this, like how we are doing. So first we will take an element like a variable answer, and we will define it 0, and we will take the XOR of answer with all the like, and we already said that answer is equals to answer XOR all the elements from the array 1, and we will got the answer here, and then we will do for the next array B, and we will got our answer here. So this is just a 2 lines of code. This is the basic how can we use the like there is no change in the time complexity, like the time complexity will still will be the O, and since the we are traversing the array with n time, like n times, so it's O of n. So like we are traversing the whole array from 1 to n, so it's O of n. So there is no change in time complexity, but this is the another way to solve the question, like how to use the XOR operator. So this is the basic like I want to give you the basic understanding like how you can use the XOR operators. So so I hope it will be very clear, not very clear, but it's clear to you. Like yeah, I will give you the Bobby, I will give you the I have one good question for this. Like I am giving the basic knowledge about the bits, like how bits is written in the code, like how you write in the code, how code will look like. And I have one question to you, one question for you, like in which we will learn like where we can use this in CP and how it will improve our computation and how it will improve our, like we can, like it's basically used for computing very fast. Like I have one good example for you, like I got your question. Like I don't want to bring this question here, but I saw your comment, so I am just taking this. Like suppose you have to multiply very big numbers. So, like, if you do by your simple decimal digits, like your calculator will be out of flow. So, what will help here us? Like, how can we multiply? Like, adding this number, like how 2 into 2 is like 2 times 2. So basically, we are adding 2 times 2. So adding this number in this many times will not be very feasible, right? So what we will do, like in this case, like if the two numbers are very big, we will use the string multiplication here. Like we will do using the bits here. So we will see that kind of questions. Like these are bit complex questions, but but we will have this kind of complex questions in the upcoming, like in the course also. Here I want to give the basic intuition. Sorry. So in before we see like as an example like how to convert the decimal to binary, so I will provide you the code here, like how code will look like, and how easy to write the code for decimal converting a number to decimal, like a decimal number into binary. So here, like we already seen the example, like how to, like I am just giving you the brief, like how to convert a number 5 to in like 5 in a decimal to binary. So it's into, and the remainder is 1, and 3 divided by 2, it's, oh, we got 2, sorry, here. 2 divided by 2 is 0, and remainder, 2 divided by 2 is 1, and remainder is 0. So we got our output here 101. So we can go through this code, like how this code is working. So I want to give you the code, like how we will write our code in while using the bitwise operator. So that's the way we can write our code. I hope it is clear to you. So we will go through this code. What is the value of n here? So n is the 5, and 5 is still greater than 0. So we will push back 5 dot push back. Like I am using the C++ here in the code. So pushback is just pushing an element in array. So 5 dot push, like here we are pushing 5 mod 2. So this mod operation will give you the reminder. So 5 mod 2 will be 1 here. So this mod operation is just give you the reminder. So we will push 1 first time, and here 5 divided by 2. Here we got the first time in the first loop, we got the value. You pushed 1 and we got the value 2 after pushing divide. So 2 is again greater than 0. So we will push 2 more 2 here. So in array we will push 0, and here again. So 2 divided by 2, we got here 1. And 1 here again is greater than 0. So we will again do that 1 mod 2. So 1 mod 2 is 1. And 1 divided by 2 is 0. So here 0. So you got here. So here got 0 is not greater than 0. So we will come out from loop, and we just reverse the array since we are pushing it. So here you will not see the difference, but if we have taken the other example, let's say we have taken the value of n will be a 4. So 4 is greater than 0. I am taking the taking values of 4 here. So 4 is greater than 0. We will go here. 4 more 2 will be 0. We have pushed in array 0, and 4 more 4 divided by 2 is 2. Same, 2 is greater than 0. So 2 mod 2 is again 0, and 2 divided by 2 is 1. And similarly, we will pass 0. So here we will get 1 mod 2 is 1, and 2 mod 2 divided by 2, 1 divided by 2 is 0. So that's the flow of code you are seeing like that. So that's like why we need to reverse the value of arrays. So that's why this, since we pushed in this order, so we want it in the reverse order, since we know that representation of 4 is 100, and we are getting 001. So we will reverse the bits of, we will reverse the numbers of array, and we will got our answer. So it's 100. So that's how the code will look like. I hope it is clear to you, like how to write the code. And so here you will need the, this is very good question, like very easy and very good question. Here you will need the uh, why we need the bitwise operation, and why where we need it in the CB. So let, I will give you time, just 2 minutes time to think about this. I hope this question is clear to you. Given an array of integer a, every element appears twice except for one. Find that single one. Like if you see here, a is like in all the elements 1, 2, 2, 3, and 1. So 2 and 1 are coming twice, and 3 is only coming once. So here the output will be 3. So, like, just think about the solution. Like, and just while thinking about the solution, just think about the time complexity and space complexity also. I think you have think of about this. So first thing what we can do here, like we can traverse the array and we can check like it's, but we have to do in the twice loops, like for 1 to n, and I is varying from 1 to n, and here for j is varying from I plus 1 to n, and we will compare like a of I is a of j, then they are the same. Then we will just compare, like, and this will be solution will be like you are comparing that this one is in this is in this array or not. So you are going to every number and checking that, and you find out that this is here. And same for 2 also, you are going for every number and you find out that this is here. So you, same for this, like we found out for this 2, again we will go for this 2 also, and we found out that it is here. Then we will go for 3. So for 3 we didn't find out in this array. So this is the time complexity for this is O of n squared. Like we are going for each array. So this is n into n. Like we are having 2 loops and we are going for in array, we are checking for every element. So like this is not an optimal solution. You are doing a simple job like finding a non-duplicate number. It's a very easy job and you are doing it in O of n square. So this is not an optimal solution. So here again, like you will get a concept of, you will need the concept of bitwise XOR here. So the solution is very easy, but you have to think of that. Like the solution is the same, like XOR of the same numbers is 0 and XOR of the different number will be the different, like 1, right? Zeros or 0 is 0, zeros or 1 is 1. So same way here we can check. So one, like here you can see like 1, 2, 2, 3, 1. So 1 will be cancelled from this one, since 1's or 1 will be 0 and 2's or 2 will be 0 again, and you will have an output. So this is the basic. I found out that this is very basic solution here. So just you have to take the XOR of all the elements and you have the answer. So this is a very good example. You have done the same job in the time complexity of O of n. Like you have reduced the time complexity by n times. Like you did the very great job. Like if you like if you interviewer ask you about this, like it's a very easy question, but it's asked in very interviews. So we have one more question. In this, you will have a great understanding of what the tricks I have shown you, and what is the need of the logical and like what is the need of the bitwise and I have shown you some tricks in the concept. So just not look into the hint and solution, just look into the question and think about of the solution. I hope you got the question's meaning. Like it's saying write a function that takes an integer and returns the number of one bit it has. So basically, it's just suppose you are taking a number. Again, I will take, like it seems like 4 is my favorite number, but I am taking it again. So binary representation of 4 is 100. So the number of one bits in this binary representation is 1. Similarly, you can see 5. In 5, it's 101. So it's 2. Similarly, you can take 6 also. 6 is 110. Again, the total bits, number of one bits is 2. So you got the question, right? In number 4, we have only number of one bits is number of one bits is 1. Number of one bits in 5 is 2. And in 6, number of one bits is again 2. So I think you got the question. So I will give you one, like there are many ways to do these questions again. So the best way I will tell you later. First, I will give you the first solution which comes in your mind. Like we just see that we can convert an element, convert a number into its binary and store it in an array, and we will count the number of ones in that array. So, like here in the question two, we will just see that, right? So we just store that in an array. We just store this 100 in an array. So we will count the number of ones in that array. So we will got like uh, that is only one time. So we will have an answer, right? So we will first what steps we will do in the first the solution which is coming to mind. I am writing that steps. First, we will convert decimal, like the number. First, we will decimal number into binary and store its representation into array, and we will traverse that array, and we will count the number of ones. So that's the one basic approach which is come in my mind. So there is no harm in that solution. Like it's very time optimized. It's not an issue here. But like here you are doing two jobs. Like, but we can optimize this code. So I will show you how we will optimize this code. Like we seen something here, right? A and a minus one. Like, did you got something here? Like we see here a and a minus one. I will let you know what a and a minus one meaning is. and it's A of number with its will clear the lowest set bit of X. So what the meaning of this? What why we are doing? Why we are clearing this? So we will take an example here. This is very interesting question, and just we are doing it in one step instead of doing it in two steps. Like first we will convert it into binary, then we will traverse that array. Here you are just doing what four and end of like just I am taking an example number A and taking end of that number with my with its one less than of that number and just doing that when the up to when that numbers becomes to zero you are doing that and you will get your answer. So this will be visible when you take an example. So that's the beauty of bits, like you will find out how good it's. So in binary representation we got like from uh, how we have got here like just counting to now I am just taking the similar example. Then you will find out how easier to write the code of this also, like just a one line code. So take a number 5 again. So 5 and less than of 5 is 4. So what we will you will get here is 101 and of 100 you will get 100 which is 4. And so output of this is 4, and initially total number of ones is 0. So after in first iteration it will become 1 and the number will become 4. So we pass 5 here. 5 is not equals to 0. 5 and logical 5 and bitwise end of 4 is 4, and like total number of ones is 1. So you can check it's just set the lowest set bit of the number. So number was 5 and it sets its lowest set bit. So it set its lowest set bit, right? You got, that's the beauty here. So it sets here and we got the 4 value, and again we will go through the loop again. So 4 is less than 0, but 4 and 3. So here we can do 4 and of 3 is 100 and of 011. So you can see here again that's the output we want to got. So it sets the again the lowest set bit of the number. So the number here was 4 and it sets the lowest set bit, so we got the 0. So here we will got the output as a 0. Now the number is 0 and the total number of ones will be 2. And we go out from this loop and we will check is a is equals to 0. Yeah, a is equals to 0 and the output will be the total number of ones. So I hope you got like how easy to use the bitwise here. Like we, above also we were using the bitwise, but here we are doing the two operation. Now we are just doing the one operation and writing just two lines of code and getting the solution of that. That's the beauty. You can reduce the, you can optimize your code length also. That's also a good measurement in like how well you write the code and how well you optimize your code, like how well you remove the redundant codes. That's the first thing company will look into the software engineers. So yeah, that's the questions I have. I will take look into the comments, like if anyone have questions. Yeah, there are many things you can do. There are, so I hope there are like, is there are any questions I can take? You can write. If there are no questions, then we can wrap up the session.
Yeah, hi.
Hey Muskan, do you have any
Hi.
questions from
Yeah,
comments?
so yeah, I was just reading the comments. I think you have addressed most of the questions. Let's just wait for another 1 minute so that if there are still any questions, they can ask. Otherwise, we can wrap up with the webinar. Guys, feel free to put your questions in the comment section right now. We will be taking all the questions. Right. Okay. I think there are no questions, so we can wrap up, Anshul.
Yeah. Thank you everyone for
Okay.
listening
Yes, thank you so
and
much, Anshul,
attending the
for
session.
such a detailed, description and such a detailed, informative session. So I think there were a lot of people throughout the session. So thank you so much for doing this. Thank you.
Thank you.
Yeah. Thank you guys for staying till the end. And as I mentioned, the live course is there, DSA Live for Working Professionals, which is at a 20% off discount. So you can use the coupon code LIV200 OFF, which is also mentioned in the on the screen. So you can use the same and avail the discount of 20% on the course, which can be really helpful to kickstart your career. And I'll see you in the next webinar. Bye.